I bet you've seen a chart like this one in the past year. Yep, this is the one that defines if we can go out or not, if we need to wear masks or not. But there's a big catch. This little guy is a big liar. Okay, I can hear you screaming at me already. Hold your horses. I'm not saying that the pandemic is a lie, or that we don't need to track data, or even that we don't need to be careful. This is all very much real. But the chart itself, oh, that's a big fat liar. Today I'm going to show you how I would go about it, what I usually do, so I can better understand not just this one, but any chart. Hopefully this helps you too. Let's go. Now, let's just start by saying charts are awesome. They really are. After all, a picture is worth 1,000 words. The problem starts when we pick the wrong picture. You know, that one where you have your eyes closed or with a fake smile. Yeah, don't pick that one. Imagine basing the biggest decisions and even your whole understanding about the world on charts that could be lying to you. Crazy, right? Now let me tell you a secret. You may not recall, but we use this type of chart a lot. You don't believe me? Well, not long ago, there was a huge concern about overpopulation. And granted, when we see this, that's pretty disturbing. Our minds automatically connect the dots, and we imagine that in a short time, things are going to get real bad. Yet, that isn't a problem anymore. Here's another example. This is the GDP of the US. Looking at it, it seems like only the sky is the limit. But as you might know, things aren't that good. What all these charts have in common, they confuse more than they explain. From the GDP chart, it's hard to tell when there's a crisis. It's impossible to compare growth between different periods. The same goes for the population or for the pandemic cases. My friend, trying to plot this kind of data in this type of chart is like trying to measure circumference with a ruler. Not gonna happen. But why? That's because these charts are representing a nonlinear relationship. Look at this chart for the conversion of US dollars to British pounds. That's linear. It's easy to predict how much you need to spend to have £1,000 in your pocket, even though that number isn't on the chart. But when it comes to nonlinear data, things get weird. Let's say a factory is producing a new product. Then we plot the number of defective pieces. In consecutive days, they are growing from 10 to 100, then 500 and 1,500. It looks like it's getting really bad, right? But the growth rate for the errors is actually slowing down. It's slowing down because there was a 900% increase in the second day, 400% in the third one, and 200% in the fourth day. Yet it looks like it's exploding. That's because our eyes are drawn to the absolute changes. And indeed, when we look at the absolute change, it's quite scary. 90 units increase, then 400, then 1,000. Absolutes are great to know the current state. They are misleading, especially when we are trying to investigate what changed and trying to predict the future. So, what's the solution? If the linear scale is the problem, we need to use a different scale, don't we? As you might have noticed, when it comes to trends, what we need to know is the growth rate, not the values. Do you have any suggestions? You might suggest plotting the percent changes. Seems simple enough, but this runs into some big problems. When we use only percentages, we can quickly lose track of the absolute values. Yep, I know, the absolute values were the problem before, but they are still important. Think about it this way, if the percent changes are minus 50%, plus 20%, plus 35%, are the positives enough to offset the first negative? Pretty hard to tell, right? And that's just 3 data points. Imagine a big chart with 20 points showing only percent change. It would quickly lose most of its meaning. Charts that show only absolute values are misleading, and charts that show only growth rates are equally misleading. Any other ideas? Maybe 2 charts overlapping. Wouldn't it work? It could, but it can get quite confusing. In particular, when we consider the alternative. What if we had one simple chart, one that shows growth data, while keeping the absolute values in sight? And for that, we just need one thing. Remember, my friend, our problem is the nonlinear nature of our data. Then the easiest solution is to linearize it. We'll manipulate our data, so what isn't linear becomes linear. This might seem weird, but I bet you've seen lots of linearization throughout your life. And you watched it recently, at the Olympic Games. By the end of a competition, players are ranked. And this ranking doesn't represent the actual performance difference between them. Quite often, players battle closely for a spot, while others are far away. Yet the ranking difference, in the end, is the same. 1 place for each. It doesn't matter if it's by 100th of a second or by minutes. Each player gets their spot. exactly 1 unit away from the neighboring spots. You can see now how ranking is a form of linearization. In our case, we use a different method, one that's quite convenient in a lot of cases, and it doesn't lose as much data as in rankings. We use a log scale in base 10. Don't get scared. You don't need to know what a log is to use it. You just need to know that the scale points in the y-axis are each worth 10 times more than the previous, which in turn makes the points in the y-axis worth 10 to the power of the x-axis points. Too many points. Let's see an example. If the first point in the x-axis is 1, the first point in the y-axis is 10. The second is 2 in the x-axis, while it's 100 in the y-axis, and then 1,000, 10,000, so on, so forth. So while in the x-axis you have numbers growing linearly, the y-axis has points growing in powers of 10. For this reason, the y-axis is in fact removing the exponential effect we had in our original dataset. It does it in a way that we can see the growth rate and the absolute values at the same time. Compare these two charts showing a simple exponential formula, 2 to the x. In the first one, it blows out of scale quite fast. In the second one, we can see that it results in a nice straight line. So, when we have a log scale, a straight line means constant growth rate. Notice, not just increase growth rate. In our example, each point is growing by a factor of 2. No more, no less. This type of chart is fine-tuned to show when growth accelerates or decelerates. Now we can look at our 3 charts. The pandemic, population growth, GDP growth. They don't seem that daunting anymore. The picture here is much clearer. Now, some tips to read a log chart. As we saw before, straight lines mean constant changes, but the slope of these lines indicates different growth rates. Look at these 2 periods for example. In both cases we can see a steady growth, but the rate of growth in the second period is much higher. Now, if you see curves, this indicates growth rate change. Upwards curves are accelerating growth, and that's what really scares me. Like in the beginning of the pandemic, we saw a big increase, then we hit a somewhat steady growth, and then a decay. This implies that downwards curves represent an accelerated decrease, while straight downward lines mean a steady decrease. The linearized chart paints a much better picture. We can see growth rate changes right after lockdowns or vaccination. You can see how it applies to the other charts as well. The GDP chart is clearer, showing crisis improvements, slow or rapid growth. The population growth shows that we can have a population decay in the future with slower growth rates. Of course, we still need to stay vigilant, but when we know what is actually happening, it is much easier to work on it. We can only improve if we measure and understand what isn't working. Imagine if we decided to stop vaccination once we saw the wrong chart showing more cases, while the log scale clearly shows its effects. There are other factors to consider as well, such as lagged variables, other linearization methods, combining different data points. All in all, the log charts are a great tool to have in your toolbox. And for a tool that can greatly improve your understanding with one click, that's pretty sweet. I hope you liked this video. See you next time. Cheers!